In the event that you are tasked with working backwards from the graph of a piecewise function to the creation of the equation slash function for a piecewise function, it is important that you follow the same series of steps that we used in the absolute value graph. Namely, we want to identify where are those breaking points, what kind of functions make up the individual pieces, and then taking our time to ensure that we've drawn or that we've written the equations correctly for each section. Now, it is fairly obvious that if I was going to write the piecewise function for this graph, that there would be three distinct sections. There is a section that comes up to -3. There is a section that goes from -3 to 1. And then there's a section after 1. You'll notice that none of those have equal to's on them. That is because I have not identified where those individual points should be at the breaking points. Who should get the breaking point for a particular section of the graph? So if I'm looking at the first section of the graph, I see in the first section of the graph as I scroll over that I am undefined on the end of this graph. I see my open circle. That means that I'm not going to want to be -3 from this section. I'm going to want to be -3 from this section of the graph, from this piece of the graph, because I have that defined point way down there at the bottom. So if I want to update my inequalities, I'm going to put the equal to on there. And then I'm going to engage in the same logic for the other side. If I follow this graph to the other end, I see that I'm undefined on my endpoint there, and I am defined on my endpoint there. So that means that I need to very carefully put my equal to on this section. Now that I've identified where all of my x's are, and I saw that where my undefined points and endpoints are going to be, I can now start to write the equation for each one of the sections. Quite obviously, each one of the sections is linear. They're a little bit different in the ways that they are linear, but they are linear nonetheless. So working from the left to the right makes the most sense. If I'm looking at this left graph, I see that I have a horizontal line, and I see that my y-coordinate is always 4, regardless of where I am on that horizontal line. That tells me that my first equation is going to be y, or f of x, is equal to 4 for that space to the left of -3. Looking at this space in the middle, I see that I have a y-intercept of -2, so I can include that in the equation of my line. I know that's going to be there. And then I have the responsibility to determine the slope of this line. So it looks like down here that I'm at the point -3, -5, and then I get to the point 0, -2. I can also see that I pass through each one of the blocks by going up 1 unit and over 1 unit. That tells me my slope is 1, so my middle section is x minus 2. For the last section, I'm in a little bit of a dicier situation because I'm not in a place where I can easily identify any slopes or any intercepts, and it's going to be a little bit more difficult to count spaces to ensure that I'm in the right place. But ideally, as I'm scanning along this line, I see that I have an x-intercept at 1.25. I also have a point down here at 2.5, -5. So I've got the point 2.5, -5, and I've got the point 1.25, 0. 0.25, 0. I can find the slope between these 2 points by subtracting the y-coordinates and subtracting the x-coordinates. So if I subtract the y-coordinates, I get -5. If I subtract the x-coordinates, I get 1.25. And if I simplify this fraction, I should get -4. So that tells me my slope of this line is -4. I still have to struggle trying to find the the y-intercept if I track this line back. Yeah, I could pull out some other tricks from Algebra 2. I could bring out point slope form. I could bring out different different manners of working with the lines. Maybe standard form might be helpful, but really it's a much easier process if you stay focused on the goal, which is I am just trying to identify whatever that y-intercept is. So similar logic to what we used for the absolute value graph. I know that this has to be true, and I know that I go through the point 1.25 comma 0. If I solve this equation for b, I get that my b must be 5, which leaves me at an intercept of positive 5. So while the first section was easily attainable, it was just a horizontal line. The second section was easily attainable. The slope was easy to count, and I actually went through the intercept. The last section was a little bit more difficult to obtain simply because of these weird intercept slash points that I needed to use in order to find the slope, which then helped me find the intercept. And one more time walking through that process, I identified 2 points that were on the green section of the piecewise. I found the slope between those 2 points, and then I used that slope with one of the points that I knew in order to figure out the y-intercept. And in case you're wondering, that is exactly how this graph was constructed. There are the 3 equations for my graph. And we end up with a nice, sound piecewise function, no overlap between the pieces. I'm very careful where to put the equal to's so that I'm assured that there's no overlap and that this piecewise function maintains the characteristics of a true function, despite the fact that it has its jump discontinuities.